express the confidence interval 74.2 to 87.2 in the form p hat plus or minus the margin of error. Now, we should first try to understand what this interval is supposed to be representing. The interval represents a range of values that we expect the true population proportion to fall in. Now, what is the population? It's not stated in this problem. We don't have any context to make it real, but it's kind of like saying that you surveyed some people to see if they recognized a certain name brand. Some would say yes, some would say no, and there would be a certain percentage, and that would be the proportion or the sample proportion if you're just sampling a few people in the population. Now, the sample proportion is going to be used to represent what we think is true about the entire population. So we have a point estimate in the sample proportion, but then we add and subtract a distance, which we call the margin of error, to get a whole range of possibilities. So I've drawn a little diagram here to illustrate this. And there you can see a number line with the interval boundaries 74.2 and 87.2 marked. And in the center, right in the middle, is our sample proportion p hat 80.7. That's the midpoint between the two interval boundaries. And so we're kind of working in reverse here, where we have the confidence interval and we're working our way backward to discover what the original sample proportion was. And the margin of error is the distance that was added and subtracted to that number. So how do we figure out these answers? So how did I get that 80.7? Well, it's the midpoint. So we add the two boundaries and divide by 2 to get 80.7. And I have also the margin of error to think about. How do I figure out what that is? Well, the margin of error is half the distance between the two boundaries. Since we're adding the margin of error on both sides of the p hat, it's a total across of 2 times that distance. So if we can just calculate the distance all the way across and cut that in half, then we'll know what the margin of error was. So how do we get the distance between two values on a number line? We subtract them, and then we can divide that by 2 to get the smaller half. So I've written out the definitions here. We have the p hat, which is the sample proportion, also the best point estimate of the true population proportion p. How do we calculate it? We take the midpoint or the average of the two interval boundaries. Then we have ME for margin of error. Sometimes you might see it marked with an E or sometimes other things, but typically an ME or just an E for the margin of error. And it's the distance to be added and subtracted to p hat. Half the distance between the two interval boundaries is how we calculate it. So I have my answers down here that were found by doing just that, adding the interval boundaries and dividing by 2 to get p hat, subtracting the interval boundaries and dividing by 2 to get the margin of error. Now my answers are in percentages, but you could also possibly give your answer in decimal form. You just have to pay attention to the instructions on whatever homework exercise or test question you are working on.